Welcome back to Low Stress Math with Mrs. Bono. We are on Chapter 2, Graphing Lines, Lesson 7, Exploring Solutions. All right, the x and y coordinates that make an equation true. That's a solution. All the points, ordered pairs on a graph, are solutions to the graph. Solutions are written parentheses x, comma y, close the parenthesis. So given the linear function y equals a half x plus 1, substitute x values into the solution to get the y values. The ordered pairs are the solutions. So if you put in -4, you get out -1. The solution is -4, -1. If you put in 0, well, half of 0 is 0 plus 1, you get +1. So that solution is 0, 1. 1/2 of 4 is 2. 2 plus 1 is 3. The solution is 4, comma 3. If you don't have the parentheses or the comma, you're going to lose points. Be careful. All right. Are these the only solutions that will make the function true? Yes or no? Well, let's talk about that. You've seen a line. How many points are on a line? Oh, that's right. It's infinitely many points. So, can these be the only solutions to a linear functional line? No, they're not. Okay, so are these the only solutions? No, they're not. No. A line has infinite points. I'm going to cheat and write infinity that way. So a line has infinite points, therefore infinite solutions. All right, so state 2 different points that are solutions to the function and 2 points that are not solutions to this function. Let's take a look at this function. It's a little light, but let's pull it up really big so it's easier to see. Well, one solution is the y-intercept, and that's at 0, 1. Another solution, wish I had my glasses on, at 1, 2, 3, 4, 3. Okay, that's this point, over 4, up 3. Right here, that is at 8, comma 5. So those are all solutions. They're things that work. So any point on this line, I'm going to use 8, 5. And let's take one that's down here at negative, let's see, what is that? -2, -3? Can't see too well. Yeah, that is -2, 0. This point right here. Now, points that are not on it anywhere else. Let's take this point up here at 0, comma 6. That's not a solution. For sure. It's nowhere near there. How about another one? How about over here at -4, -4 down here? -4, -4 is not a solution. How do I know those are not solutions? How do I know that those are not solutions? Well, they're not on the graph of the line. All right, so any point on the line is a solution. Any point not on the line is not a solution. So let's write that down. Any point on the line is a solution. Any point not on the line is not a solution. any point on the line is a solution, any point not on the line, not a solution. Okay, let's take a look at the next page. Here we go. State 2 points that are solutions to the function and 2 points that are not solutions to the function. And now we've got an interesting function there. Y equals x squared minus 2x minus 3. Well, that's a heck of a thing. Now we do intercept the y, but it's not at -3. It's at -1, -2. It is at -3. I am a liar. -3. But there's other points. This point where it turns, which is at -4. Sorry, +1, -4. Yes. And this point, which is at 0, 0, 3. This other point, which is at 0, -1. Those are all, oh, should have done them in blue. Those are all points that are on the line. Let's just pick 2 of them. So 0, -3. And look at me getting these completely backwards. -1, 0. And this one, which is at 3, 0. Wow, I need to wake up this morning. Points not on the line, anything over here. -6, +8. Yeah, that's like -6, +3, right? -4, whatever. And somewhere over here, which is at +5, +3. Anything that's not on the line is not a solution. Anything on the line is a solution. Any point not on the line is not a solution. So it doesn't matter if it's the graph of a line or this is a parabola, or if it's a graph of a parabola. If it's on any point on the graph is a solution. Any point not on the graph is not a solution. The graph is the U shape. The background, you can either call it graph paper, or you can call it a grid, or you can call it a coordinate plane, but the graph itself, that's the parabola. Down here, the graph itself is this line. So that's the graph. All right, the graph of the function is shown below. That's nice. Which of the following ordered pairs is not a solution? Well, I would just graph all of those points. -2, -1. All right. -2, -1. That's not a solution. -3, -4. Ooh, that's down here, way down here. We don't know. It's not, it's down here somewhere. 0, 2. It's not a solution. And what's this? 2, 5 over 2 up 4, 5. Yeah, 2, 5. None of those seem to be on the line. Huh. You know, we could actually check this using a chart. X's and Y's. Let's do -2, -3, 0, 2. I should reverse those, but that's fine. And then we're going to put them into 3x plus 4. 3 times -2 plus 4 is, let's see, that's negative 6. Negative 6 plus 4 is negative 2. So that's not on. This is definitely not on the line. 3 times negative 3 is negative 9, plus 4 is 5. That's definitely not on the line. 3 times 0 plus 4 is 4. That's not on the line. And 3 times 2 is 6, plus 4. Well, what's 6 plus 4? That's 10. So that's not on the line. Huh. Which of the following ordered pairs is not a solution to this equation? None of those ordered pairs are solutions to the equations because none of them are on the graph of the line. So, none of those points are solutions. They are not on the graph of the line. Sorry. Huh. Which is kind of interesting. None of them work. All right, let's try the next page. We can explore solutions to a function algebraically. That's what I was doing on the last page when I made that little chart. So we are going to substitute that point in here, and let's see if it works. So here we go. Y equals 4x minus 3. And instead of y, I'm going to put the 5. Remember, it's x, y. So 5 equals 4 times 2 minus 3. 4 times 2 is 8, so 5 equals 8 minus 3. 5 equals 5. It works. Yay. So here's the justification. Justify my answer. 2, 5 is a solution to y equals 4x minus 3 because the solution is correct, because the substitution is correct. Works in the equation. Okay, let's try the next ordered pair. Again, it's xy. So we're checking that point in that equation, which is the same equation, so that's nice. I don't think this one's going to work, though, because it doesn't look like it should. Y is negative 1. Sorry, blah, blah, blah. Y equals, no, y minus 4x equals negative 3. So, negative 1 minus 4 times 1 equals negative 3. Negative 5, well, that's not equal to negative 3. Oh, well, this is equal. Can't, but that's not. So, the point 1, negative 1 does not work in the equation y minus 4x equals negative 3, so it is not a solution. All right, so now I'm going to introduce you, well, do the next one yourself, and then we're going to talk about wording. Come on, stop the video, check it. You can do this. Okay, welcome back. Let's try this. Here we go. The ordered pair 4, 3, a solution? Is it? Let's find out. Here we go. This is the x, this is the y. 2y equals negative 6x plus 10. Wow, that's a lot. 2, remember, substitute correctly. 3 equals negative 6 times 4 plus 10. Okay, 2 times 3 is 6. Negative 6 times 4 is negative 24 plus 10. Negative 24 plus 10 is, negative 6 is not equal to negative 14. Okay. I didn't use the correct wording before. It should, instead of saying it works in the equation, you should say it satisfies the equation. So that does not satisfy the equation. The point, four, 3 is not a solution because it does not satisfy the equation. So the point 4, 3 is not a solution because it does not satisfy the equation. All right, let's try the next one. Substitute the given into the solution to solve for the remaining variable. Okay, so what is the solution? A solution is two numbers. It's not one number. So if they give you one number, you have to find the other number in order to have a solution to the equation. So let's try this. 3x minus 6 equals y. And we know the x is 4, so 3 times 4 minus 6 equals y. 12 minus 6 is y. 6 equals y. The solution is both numbers. It's the x, 4, and the y, 6. This is a y. So it's both numbers, x and y. What is the solution to this function when y equals, okay, now they give us y, so let's try that. 3x minus 6 equals y. 3, we don't know what x is. That's what we're looking for. Minus 6 equals 9. You gotta substitute the right thing. Okay, add 6 to both sides. 3x equals 15. Divide by 3. X equals 5. The solution is both numbers. It's the x and the y. So 5, 9. And get them in the right order. A little bit more, and then you're on your own with some independent practice. Here we go. So, what is the solution when x is negative 1? Oh, I don't know. What is the solution when x is negative 1? I gotta move my nose. Oof. I can't find my tie shows. Dang. Okay, here we go. 3x minus 6 is y. Okay, x is negative 1, so 3 times negative 1 minus 6 equals y. That's negative 9 equals y. So my solution is negative 1, negative 9. Remember x, y. Get it in the right order. And the last one, 3x minus 6 is y. Substitute for y. So 3x minus 6 equals negative 3. Add 6 to both sides. 3x equals 3. Divide by 3. X equals 1. Make sure you put them in the right order. X, y. So you get 1, negative 3. Okay, good luck. Independent practice on this page. Take care. See you soon.